Welcome back, everybody. We are up to lessons 8 and 9. This video will cover both lessons 8 and 9. So in these particular lessons, we are learning about another form, another way of expressing the terms of a sequence. We've previously talked about the recursive form or the recursive definition. In this lesson, we're going to talk about something called the closed form, also known as the explicit form, also known as the nth term. All three of these mean the same thing: closed form, explicit form, and nth term. And it's a formula that directly computes a specific term of a sequence. And the key, it is not necessary to know the previous term. Like I said earlier, we've talked about the recursive form before. One of the disadvantages of the recursive form is that you have to know each of the previous terms in order to find a new term, which is fine at the beginning of a sequence. But if I gave you a pattern and said to find the 100th term of a sequence, and you had a recursive definition, well, to figure out the 100th term, you would have to know the 99th term. And to figure out the 99th term, you'd have to figure out the 98th term. And to figure out the 98th term, you'd have to know the 97th term, so on and so forth. You'd have to figure out each term prior to that. Well, this new form, the closed form, the explicit form, the nth term, you don't need to know that. You can just plug right into a formula and figure out a specific term of a sequence. So if I have a geometric sequence, this is the formula right here. All I need to know are my starting term, my common ratio, and which particular term I'm looking for. Same thing with arithmetic sequences. All I would need to know is the starting term, the common difference, and the term that we're looking for. So that's closed form or explicit form or nth term. So with that in mind, let's go ahead and get to the examples here. So Claire takes a piece of paper with length 8 inches and width 10 inches and cuts it in half. Then she cuts it in half again and again. So Claire takes a piece of paper with length 8 inches and width 10 inches and cuts it in half. Then she cuts it in half again and again. Instead of writing a recursive definition, Claire writes C of n equals 80 times 1/2 to the power of n, where C is the area in square inches of the paper after n cuts. Explain where the different terms in her expression came from. So in other words, what does the 80 mean? What does the half mean? Okay, so 80 in this case, that is going to be her starting area. In other words, it's going to be the area of the original paper. Now, where did that 80 come from? Well, the original paper had a length of 8 and a width of 10. And we know that the area is length times width. Well, what's 8 times 10? 8 times 10 is 80. So 80 is your starting area. And then the half is going to be your common ratio. Okay? Why is the common ratio half? Because you're cutting it in half. You cut it in half, then you cut it in half again, then you cut it in half again. So your common ratio is a half. Okay? And if you go back to the lesson notes and look at the closed form or the explicit form or the nth term formula for a geometric sequence, what do we have here? Well, f of 0, which was 80, times a half to the power of n. Our common ratio was a half. So this right here is the nth term, or the closed form, or the explicit form of this particular sequence, of this particular situation. Part B, approximately what is the area of the paper after 10 cuts? So I have this closed form here. I want to know what it is after 10 cuts, so I'm going to plug in 10 for n. So I need to calculate 80 times a half to the power of 10. So 80 times a half to the power of 10 is going to give me the area after 10 cuts. So 80 times a half to the power of 10. Whoops. There we are. So this would be the area after 10 cuts. So it would be approximately 0.08 if we round. So it'll be approximately 0.08. Number 2, Kieran takes a piece of paper with length 8 inches and width 10 inches. So same size piece of paper, same area. So our starting area is going to be 80 again. So he takes the paper and cuts away 1 inch of the width. Then he does it again and again. So the width is 10. So after one cut, the width becomes 9. And then the width becomes 8, and then 7, and then 6, so on and so forth. So to figure out the area after one cut, well, my length is going to stay the same, but my width is going to go down by 1. So my width is going to go from 10 to 9. So my new area is going to be 8 times 9, which is 72. Okay. Now notice they filled in 2 here. Okay, notice it went down by 8. So for 2 cuts, that would mean he took 2 inches off the width. So the width is now 8 and the length is now 8. So our area is now 64. You could also think of it as subtracting 8 twice, because I subtracted 8 off the area when I made 1 cut. So when I subtract 8 off the area again for 2 cuts, that would give me 64. Okay? So if we follow this pattern, 3 is going to be 80 minus 8 minus 8 minus 8. I'm going to subtract 8 3 times, which is the same as 80 minus 8 times 3. So what is 80 minus 8 times 3? So that's going to be 80 minus 24, which is going to be 56. So number 4 is going to be 80 minus 8 times 4, which is 80 minus 32. So that's going to be 48. And number 5 is going to be 80 minus 8 5 times. So I have to subtract 8 5 times. So that's going to be 80 minus 40, which is 40. Okay. So Kieran says the area after 6 cuts in square inches is 80 minus 8 times 6. 80 minus 8 times 6. Explain where the different terms in his expression came from. So I'm going to do that up here. So 80 minus 8 times 6. So first of all, what does the 80 mean? Well, 80 is the same as it meant up here. It's the area of the original paper. It's the area of the original paper. It's our starting area. Okay. What is the 8 here? Well, in this case, after each cut, notice each time the area goes down by 8. Each time the area goes down by 8. So it's the amount it goes down each cut. So it's the amount the area goes down per cut. So after one cut, it goes down by 8 once. After 2 cuts, it goes down by 8 twice. So on and so forth. Okay? And the 6 here is the number of cuts, right? Because he's trying to find the area after 6 cuts. Okay? So 80 minus 8 times 6. That answers the question. Explain where the different terms in his expression come from. Okay? C. Okay? Write a definition for k of n that is not recursive. So we're going to use this closed, explicit, or nth term form. Well, the easy way to do it is just to take up here 80 minus 8 and replace the 6 with an n. So k of n equals 80 minus 8n. And if we go back and look at our lesson notes, okay, f of 0 is my starting term. That was where the 80 comes from. Notice it's a minus because we're going down. It was minus 8 because we're going down by 8 each time. So 80 minus 8n. So write a definition for k of n that is not recursive, 80 minus 8n. And 3, which is larger, k of 6 or c of 6? Well, k of 6, if I were to make an extra row here, k of 6, it goes from 48 to 40, so k of 6 would be 32. Okay? So k of 6 would be 32. Okay? What would c of 6 be? Well, up here, I'm going to take this formula, and I'm going to plug in 6 for n. So it's 80 times a half to the power of 6. So I'm going to take this and replace the 10 with the 6, and it's 1.25. So k of 6 is 32, c of 6 is 1.25. So which is larger? K of 6 is larger. K of 6 is larger. So that's how we did it. We did it by finding the terms and figuring out which one was larger. Now, another way you could have done it is by considering the type of sequences these are. I knew that C is a geometric sequence and K is an arithmetic sequence. C, because it's geometric, is exponential. K, because it's arithmetic, is linear. Now, what type of graphs are going to decrease faster? They're both decreasing, but what type of graph will decrease at a faster rate? Is it going to be an exponential graph or is it going to be a linear graph? Well, it's going to be the exponential. An exponential will always decrease at a faster rate than a linear graph. So C is going to decrease at a faster rate, which means K is going to be the larger one. So that was another way you could have answered number 3 without actually finding the value of K of 6 and C of 6. That is it for this lesson.